Hello everyone. Today we are going to discuss classification of elements, its periodic properties. Means basically we are going to deal the periodic table in which elements are classified into various groups. So before starting with this classification, we'll discuss genesis of classification, historical background for this classification of elements, how different types of classification of elements are given by different scientists, and what is the basis for classification of these elements into different groups. So now coming to this, we are going to classify these elements into various groups. And these class elements that we have classified is arranged in a table which is known as periodic table. So periodic table is a table in which different elements are arranged in order of their properties, similarities in order of their properties. So elements with properties similar are placed in a vertical column, and that particular arrangement in which the elements are arranged in a tabular form, that is what we call as periodic table. So starting with the genesis of classification. Classification of elements, that is periodic table. So let's go into some historical background for the classification of these elements. First we have Dobberinier law of triads. First classification is Dobberinier law of triads. Triad stands for a group of three. Now Dobberinier tried to classify elements into group of three in such a way that the middle element, the atomic mass of middle element comes out to be the average of the first two elements. So these elements are grouped into three in such a way that the atomic mass of middle element is the average of the two. So we have this class group place elements into a group of three. Look at this: lithium, sodium, and potassium. So we classify these elements into these three groups: lithium, sodium, and potassium. Lithium atomic mass is 7, sodium 23, potassium 39. So atomic mass of sodium is the average of this lithium and sodium. So look at this: 39 plus 7 by 2, that is 23. So the atomic mass of middle element, that is sodium, is average of the first two elements. So we have this is doberilious triad. Similarly, we can have look at this chlorine, bromine, iodine. Chlorine is 35.5, bromine 80, 127. So I can look at this 127 plus 35.5 divided by 2, that is 162.5, that is approximately 81. So again look at this is approximately equals to the atomic mass of bromine. In this way we have calcium, strontium, barium. So the atomic mass of strontium is average of calcium and barium. So this is what we call as Doberilius law of triads. Now look at this, basically is applicable for very few elements, and this is not applicable for all the elements. So this was limited to very small group of elements, so this cannot be accepted. So this is what we call as Doberilius law of triads. Second one is Newland law of octave. Newland's law of octave. Octave stands for 8. So according to this Newland's law of octave, when elements are arranged in order of increasing atomic mass, so elements are arranged in order of increasing atomic mass. So when elements are arranged in order of increasing atomic mass, then every nth element is found to be having properties similar to that of first element. So there is a repetition of the properties after every nth element. So this repetition gives rise to the law of octave. This law of octave is similar to that of 8 musical notes like sa, re, ga, ma, pa, dha, ni, sa. So the 8th one again repeats here. In the same way, when elements are arranged in order of increasing atomic mass, every 8th element is found to be having properties similar to that of the first element. When elements are arranged in order of increasing atomic mass, the 8th element were found to be similar in properties with the first element, that is similar to 8 notes of or 8 musical notes. So we have a group of elements, that is lithium, beryllium, boron, carbon, nitrogen, fluorine, and the next element sodium. So there is, after this chlorine we have element sodium. The sodium is having properties similar to that of element lithium. So this is similar to 8 musical notes: sa, re, ga, ma, pa, tha, ni, sa. Oh, sorry. Oxygen, fluorine, so, sa, re, ga, ma, pa, dha, ni, sa. So the 8th note is having properties similar to that of the first. So this is law of octaves. But the problem lies here. This law of octave is applicable for elements only up to atomic mass 40. Problem. Applicable up to lower atomic mass, that is 40 up to calcium. Second location is this law of octave was given before the discovery of noble gas, but after the discovery of noble gas, this gets disturbed because look at it, after this we have the 17 group element that is fluorine, we have noble gas that is neon. So look at it, the 8th element is noble gas. So this was given before the discovery of noble gas, but after the discovery of noble gas, this gets disturbed. After the discovery of novel gas, because look at it, the 8th element comes out to be novel gas, so this cannot be having properties similar to that of the first element. So this is Newland's law of octave. So why we classify elements into group of 8 based on similarity, but before the discovery of the noble gas. After noble gas, this cannot be the criteria for classification of elements. Then the third classification, that is Lothar-Meyer curve. Now Lothar-Meyer again tried to classify elements based on certain parameters when he gave a graph of atomic volume versus atomic mass. So he tried to find out the reason between atomic volume and atomic mass. So when we made a graph or a plot between the atomic volume and the atomic mass versus atomic volume, he found it such type of graph. So the similar positions of the graph were occupied by elements having similar properties. So look at this, these peaks in the graph, these peaks were occupied by alkali metals. So alkali metals occupies the peak position in the graph between atomic volume and atomic mass. So since similar elements occupy similar positions here, so all the peak positions of this atomic volume versus atomic mass were occupied by alkali metals. And this ascending portion, this is ascending portion. The ascending portion, all these ascending positions were occupied by electronegative element, ascending position, these were occupied by electronegative elements. So elements with similar properties were found to occupy similar positions in the graph of atomic volume versus atomic mass. But the problem lies is for each and every element it's not possible to find an atomic volume because at that particular instant of time, science was not as far as developed as we are today. So the instrument part for defining atomic volume, that means atomic volume could not be measured accurately at that particular time. So again this was, but he tried to classify all the available elements based on this. Then we have next Mendeleev's classification. Mendeleev's classification. Now, Mendeleev was the very first scientist who tried to classify all the available elements of his time into certain set of characteristics. So, classification of elements basically is credited to Mendeleev because he was the first scientist who classified all the elements available at this time. So he found it the classification of elements into certain periods or certain groups should be based on atomic mass. So based on this, he gave a periodic law. So this classification is based on atomic mass. So Mendeleev's classification of elements is based on atomic mass, and based on this he gave a law, periodic law, that is Mendeleev's periodic law. So according to this, he said the properties of elements, that is chemical as well as physical properties of elements, are the periodic function of their atomic mass. That means the chemical as well as physical properties of elements depends on the atomic mass. So according to this law, the properties of elements are periodic function of their atomic mass. So this is what it was Mendeleev's periodic law. That means he arranged the elements in order of increasing atomic mass. That is, elements were arranged in order of increasing atomic mass. So elements were arranged in order of increasing atomic mass. So these Mendeleev's classification, the basic features, of Mendeleev classification is this contains groups. Total 9 groups were present. Groups means vertical columns. So first is basic feature, or very important basic feature of this classification, it contains groups. Total number of groups is 9, that is 0, 1, 2, 3, 4, 5, 6, 7 and 8 groups. These are total 9 groups, that is consisting this Mendeleev's classification of element. Accepting this 0 and 8, with exception of these two, the remaining groups, that is 1, 2, 3, 4, 5, 6, 7, each group is subclassified into subgroup A and subgroup B. That means this A contains subgroup A, 1A, subgroup B, that is 1B. Similarly, this 2 also contains subgroup A, subgroup B. That means all these elements, so all these groups 1, 2, 7, each group is subclassified into subgroups, subgroup A and subgroup B. Except this zero group and the 8 group, each group from 1 to 7 is subclassified into subgroup A and subgroup B. So total number of group is 9, 0 to 8, and 0 except this 0 and 8, each group is subclassified into subgroup A and subgroup B. Then we have periods. Periods is horizontal row. Total number of periods in Mendeleev's classification is 7 periods. Now, this first period and second period, third period, these are short period, means number of elements in first, second, third is less. Then 4 and 5, this is long period, means containing more number of elements. 6 longest. 7, that is incomplete, means many more elements are yet to be discovered. So Mendeleev's classification element, the basic features is it consists of groups and periods. Total number of groups is 9, that is from 0 to 8. Except 0 and 8, each group is subclassified into subgroup A and subgroup B. And the total number of periods means horizontal rows. So total number of periods is 7. So all of these first period, second period, and third period is known as short periods containing less number of elements. 4 and 5 contains long period, known as long periods, means more elements are present. The longest is 6, and 7 is still incomplete, meaning there are many more elements are yet to be discovered. So this is Mendeleev's classification. Now let's go to the advantage and disadvantage of this classification. Advantage of Mendeleev's classification of elements. The first advantage of this classification is, now look at these elements were grouped according to their properties similar. So the chemical as well as physical property of each and every element cannot be identified accurately. So to overcome this, he placed a group of elements in a particular period or a group having properties similar. So generalization of the chemical properties or characteristics of elements become much more easier. That is generalization of properties. The second important feature of this classification is correction of doubtful atomic mass. Correction of doubtful atomic mass. So while elements are arranged in order of their increasing atomic mass, before his classification, the atomic mass of certain elements were found to be doubtful, but when this Mendeleev gave the classification based on this increasing atomic mass, he corrected those doubtful atomic mass like beryllium before this classification, its atomic mass considered to be 35. But after this Mendeleev classification, he corrected the atomic mass of this beryllium to be 2. By this way, many more elements available during this period, those elements having doubtful atomic mass were found corrected by using this Mendeleev classification. Third, and this is very important point of this classification, Mendeleev realizing that the elements available at his time were incomplete, means many more elements are yet to be discovered, and elements which are going to be discovered, for those elements he left a number of unoccupied or number of unoccupied space, and that unoccupied space, he says, these are the elements likely to be discovered in their future, and those elements which are yet to be discovered should be having properties similar to that of elements present in that particular group. So, for elements yet to be discovered, he predicted their properties, but elements were yet to be discovered, so he kept a place a gap. So, he introduced a number of gaps for elements yet to be discovered. So, like look at this elements: germanium, gallium were not discovered at that time. So, he predicted the properties of germanium and gallium. So, after this silicon, he placed a gate. Similarly, after this aluminum, again he placed a gate. So, this element next to silicon was yet to be discovered, and element next to this aluminum was yet to be discovered. So, this element yet to be discovered, he placed this as Eka silicon. That means this element whose properties should be similar to that of element but yet not discovered. So later on, he predicted the properties of this Eka silicon to be the properties similar to that of silicon, will have properties similar to that of silicon, but element is not yet discovered during his time. So he predicted all the properties of this element to be discovered, which is placed next to silicon, and later on this silicon, Eka silicon, was found to be germanium. So he predicted the properties of aluminum, germanium, and he says this Eka silicon, that is germanium, should be having properties similar to that of element, silicon. Similarly, after this element, aluminum, the next element should be having properties similar to that of aluminum, but not yet discovered. So he called this element to be Eka aluminum, that is element having properties similar to that of aluminum, and later on this element was found to be gallium. So he predicted the properties of some elements yet to be discovered and the position for these elements to be placed. So this is some of the advantages of this Mendeleev's classification. Along with this, let's see some of the disadvantages of this classification also. Disadvantage. While discussing the disadvantage of Mendeleev's periodic table, first thing that comes to mind is the position of hydrogen. The first and the lightest and the simplest element, hydrogen. Normally, hydrogen is placed along with group 1. But when we look at these properties of hydrogen, this hydrogen shows properties similar to that of group 1 as well as group 17. So these two is this element having properties similar to group 1 as well as group 17. Now the question is why this should be placed along group 1, why not along with group 17, or why this cannot be placed with group 17. So the position of hydrogen is still controversial. There should be a separate position for hydrogen, but normally in the periodic table this is placed along with group 1, that is alkali metal. So this becomes a disadvantage. Second disadvantage is now the groups except this 0 and the H group 1 to 7 is subclassified into subgroup A and subgroup B. Now when he classified these elements into subgroup A and subgroup B, no correlation was found between elements of subgroup A and subgroup B. That means different elements having different properties were found in a particular subgroup, and different elements having same property were found to be in different subgroup. So no correlation between the elements of group A, subgroup A and subgroup B, though they are placed under same group. No correlation between elements of subgroup A and B. In many of the cases, he violated this rule. Number 3. Now he arranged elements based on increasing atomic mass. The basis of his classification is atomic mass. So elements were arranged in order of increasing atomic mass. So many times during his classification of elements based on atomic mass, he himself contradicts this basis of classification, meaning thereby many elements having higher atomic mass were found to precede the element having lower atomic mass. So he could not explain why certain elements having higher atomic mass should be placed before the element having lower atomic mass. So look at this: argon and potassium. So if you look at this, the atomic mass of argon is 39.9, but potassium is 39.1. So if you look at this periodic table, in this classification, element argon having higher atomic mass based on this law should be coming after potassium. But if you look at this, argon comes before. So why these elements having argon having greater atomic mass precedes potassium having lower atomic mass in the periodic classification? So he himself contradicts this. Similarly, cobalt and nickel, the atomic mass of cobalt is greater than nickel. So cobalt, why is cobalt having greater atomic mass should precede nickel? So he could not explain. So in some of his classification, the element with high atomic mass precedes the element with lower atomic mass. So he himself could not explain why this discrepancy happens. Number 4. The position of lanthanides and actinides. If you look at the periodic table, there are a group of 14 elements known as lanthanides and actinides which are placed below the main periodic table. So he could not include these 14 lanthanide and 14 actinide elements in the main periodic table. So this is again a very important disadvantage of this metallic classification. Apart from this, when we discuss the classification of elements, first thing that comes to mind is metallic classification. Why? Because he was the very first scientist who tried to classify with certain reason the whole elements available at this time. So this is metallic classification of elements. Then next thing is modern periodic table, modern classification. Modern classification. This modern classification is also known as long form of periodic table. Long form of periodic table. This modern classification of elements, this is based on atomic number rather than atomic mass. So while mentally the recent date, the properties of elements were related to atomic mass, but modern periodic classification says the properties of elements are a function of their atomic number rather than atomic mass. Now, these modern classification, there is classification of elements based on this atomic number, is based on Moseley's law. So he was a scientist who opined that the properties of elements should be more related to atomic number rather than atomic mass. So what Moseley did was the characteristics X-rays generated from different elements. He take different elements. These elements were struck by some heavier elements when these releases characteristics X-ray. So the characteristics X-rays of these different elements, he made a graph between the frequencies of the characteristic X-rays generated from different elements with their atomic number as well as atomic mass, and later on he found that the relation or the graph between the frequency of the characteristics X-rays and the atomic numbers were found to be straight line rather than the frequency versus the atomic mass. So this is frequency is this is frequency of X-ray. Generated from different elements. A and B, this is constant characteristics of a given element. Z, atomic number. So he take different elements. From these different elements, X-rays were different, generated, and he made a graph between X-ray, frequency of X-ray and atomic number, and he found the graph to be. So look at, this is the basic equation. The same can also be written as, look at this, frequency is equals to Aj minus AP, that is the graph B. Now frequency can be related C by lambda, that it is A J minus B or Aj minus AB. Now therefore look at this, 1 by lambda is equals to A by under root C J minus B. These are different forms of the same equation. You can look at this. C is equals to, we are taking into. So taking this, look at this equation 1, equation T. So we have this frequency and atomic number. This is Listen, J minus B versus frequency. So if you look at this is an equation of straight line passing through origin. So this gives this graph. So if Z minus B equals to 0, frequency is 0. If Z minus B is having some positive value, this becomes some positive value. So it increases in a straight line, and this slope of the graph is equals to A. That is equation A. Take this equation B, we have as usual frequency and Z. Now look at this. If Z equals to 0, frequency is equal to minus AB. 0, this is positive value, this is negative. So Z equals to 0, when Z comes out to be 0, frequency is equals to minus AB. So we have this. Now if Z increases, if the value of Z increases, this difference decreases, so this keeps on decreasing. And ultimately a particular stage comes when AJ equals to AB, so frequency comes out to be 0, then finally this increases. So AJ, the value of AJ is greater than AB, then this finally increases. So look at this particular frequency is 0. At this point, frequency is less than 0. Beyond this, frequency increases. So if you look at this, slope of the graph, slope is still at A, and this y-intercept, this is equals to AB. So from the intercept of the graph, we can define the value of AB, and from the slope, we'll find the value of A. So once we have the value of slope and intercept, we can find the value of B. So the value of B is intercept divided by slope. This gives you the value of B. So look at this. B will be equals to intercept, just suppose this is OX divided by slope. So this is AB by A. So this comes out to be the value of B. So from this graph, we can define the value of A as well as value of B. Now this is equation B. Now look at this equation C. Equation C is wavelength versus atomic number. So we have this 1 by wavelength versus Z minus D. So this gives a graph passing through origin, but the slope will be A by root C rather than A. So if the graph is between wavelength and atomic number, slope is, take the same graph, one by square root of wavelength versus Z. So if this is the graph, then if Z equals to 0, so we have minus AB by C. That is degree. So यहाँ पे जो slope is still A by C, but this distance will be equals to AB by under root C. So this is the nature of different graphs. So he found the graph between frequency and atomic number to be straight line. So based on this, he says the properties of elements are more fundamental to atomic number rather than atomic mass. So based on this, he developed a periodic law. So let me rub this. So modern which says the properties of elements are periodic function of atomic numbers rather than atomic mass. So Mendeleev says the properties of elements are more fundamental to atomic mass, whereas modern classification or Moseley's law or the modern periodic law says the properties of elements are more fundamental to atomic numbers rather than atomic mass. So the Mendeleev periodic law says properties of elements are periodic function of their atomic numbers. Mendeleev's law says periodic properties of elements are periodic function of their atomic mass. This is atomic number, Mendeleev's is atomic mass. So in this modern classification of elements, elements are arranged in order of increasing atomic numbers rather than atomic mass. Elements are arranged in order of increasing atomic number rather than atomic mass. And while these elements are arranged in order of increasing atomic number, elements with similar electronic configuration were found to have similar in properties, and there is repetition of elements after certain atomic number. That repetition of elements having same properties were placed in a particular group. So those elements placed in a particular group were found to be having similar electronic configuration, and those elements are found to be having similarities in their properties. So this is the modern periodic classification, and the basic features of this modern classification. The basic features. Now the basic features of Mendeleev were still retained by this modern classification, that is groups, also known as vertical columns. So still modern classification is the total vertical columns or groups were 18 rather than 0 to 8, with each group classified into subgroup A and subgroup B. So modern classification says total number of groups or vertical columns is 18, and elements placed in a particular group has similar electronic configurations. So those elements having similar electronic configuration are placed in a group, and these elements in a group will have properties similar. So generalization of properties of elements in a particular group can be very easy. So we can have this. So total number of groups is 18, that is from 1 to 80. Then we have periods or horizontal line rows. Still, this is 7. First period, this contains 2 elements, that is shortest period is first period. Second period contains 8 elements. Third period still contains 8 elements. So these 1, 2 and 8, these are not a short period. The short 1, 2, 3 is not a short period because this contains less number of elements. So all of these, 1 contains only 2 elements, that is the shortest. 2 and 3 contains 8 elements. 4 contains 18 elements. 5 also contains 18 elements. So these 2 periods, these are known as long periods. Then we have 6, this contains 32 elements, that is longest. 7 period, this is incomplete, means many more elements are yet to be discovered, but as for electronic configuration, this must also contain 32 elements. 7 is still incomplete, but if this is complete, then this will also contain 32 elements. So the basis of this modern classification and the Mendeleev classification remains same. So both contains groups and periods. Number of groups is 18 in the Mendeleev's case, except each group was subclassified to subgroup A, subgroup B, but there is no subgroup A, subgroup B. Total groups is 1 to 18. Period still remains 7. So coming to advantage of this, so while arranging elements in increasing order of atomic number, the discrepancy that were observed in case of Mendeleev, like some of the elements having higher atomic mass comes before the element with lower atomic mass. So no such discrepancy exists in case of modern periodic table. So look at this: argon atomic number 18, potassium is 19. So argon atomic number 18 comes before potassium. Similarly, cobalt atomic number 27, nickel 20, so cobalt comes before nickel. So while arranging elements in order of increasing atomic number, no discrepancy corresponding to atomic mass were observed. Second, there is no subclassification into subgroup A and subgroup B. So all elements placed in a particular group has got similar electronic configuration, and those elements having similar electronic configuration will have similarities in properties. And this is not something like elements in subgroup A, elements in subgroup B, in which there is no correlation found in case of Mendeleev. Third, one of the very important disadvantages of Mendeleev was the position of isotope. So I forgot to mention the position of isotope. So Mendeleev says elements are arranged in order of increasing atomic mass. So most of the elements has got isotopic forms. So isotopes are elements having same atomic number with different mass. So if elements are increasing in arranged in order of increasing atomic mass, so there must be separate position for different isotopes. So this was one of the very important disadvantages of Mendeleev. So no separate position for isotopes were mentioned given by Mendeleev. Now look at this. Modern periodic classification says elements are arranged in order of increasing atomic number rather than atomic mass. So if the element is having same atomic number, whether we are having 5 isotopes or 3 isotopes, they should be still placed in the same group because they have same atomic number, same electronic configurations, because properties of elements are fundamental to their atomic number. So this is advantage of modern. Still, we have some disadvantage in this modern classification also. Again, the same question, that is position of hydrogen. So in modern periodic classification, again, hydrogen is in most of the time placed along with first group elements, though the properties are similar to first group as well as the 17th group. So this hydrogen should have its own separate position in the periodic table. So the position of hydrogen is still controversial in modern periodic table. And one of the again disadvantages of this modern periodic table is, if you look at this modern periodic table, below the main table there are two separate rows, each containing 14 elements. The first row is known as lanthanides, the second row is known as actinides. So these 28 elements of lanthanides and actinides, there is two rows of elements, each containing 14 elements, would not be placed or accommodated in the main periodic table. These are always placed below the main table. So again, this is the disadvantage both in case of Mendeleev and the modern periodic table. So this is the genesis of the classification of elements in the periodic table. So So the more important classification is mentalist classification and the modern classification of elements. So this is all about the historical background for classification of elements in modern periodic table.